I'm a big why guy. Why is something the way it is? And right now I've been wondering, why is NVIDIA worth $3.1 trillion? I think it was actually at like 3.4 trillion. But as of the day of this recording, it's at 3.1. Who cares? We're talking about numbers that just don't even matter anymore. It's money. Money's nothing at this high level of trillions of dollars. But why? If you've grown up in the gaming space, the PC gaming space, yeah, you know NVIDIA. They make GPUs, but there's also AMD. There's also recently Intel. I would say mostly if you've grown up doing it, it's been AMD versus NVIDIA. But what the hell happened? Why did NVIDIA just take so far off? And really, it's this. Let's look at the Sankey chart. If you never looked at one, it's pretty straightforward. On the left, you got the cash flow input. On the right, you can see in red where cash flow is going out. Then you can see actual leftover profit in the green. And big number here, data center, the enterprise space. Gaming as a consumer, sure, we're talking billions of dollars, $2.9 billion in this last earnings report. But data center, these enterprise massive, highly computational powered GPUs are going towards, and I looked at their latest 8K, their earnings statement. It's the Google Cloud Platform, it's Microsoft Azure, it's Amazon AWS, and they're just pouring money into it as things like ChatGPT, generative AI models have come into the normal lexicon, everyday use. That's what you need. You need these massive GPUs. Now, many people are wondering, why not CPUs? What happened to those? Well, those are still the brain. You still need the CPU, but CPU requires or performs sequential processing, one task at a time. Not really great when you're training these massive data sets and these really sophisticated neural networks and need to be training things all in parallel. And that is why GPUs have become very useful in this space. It's the parallel processing. And as far as I know, no one does it as well as NVIDIA. Why? CUDA. It's this underlying platform that they have built onto their GPUs to maximize the parallel processing efficiency. And it has had support for a number of years. CUDA actually got established, I think, in like 2006. And so they have a hell of a head start from people like ROCm Platform, which is AMD's equivalent, which started, according to even their own website, 10 years after NVIDIA. And when you have a decade-long head start, you've got all of these developers that have gone into the machine learning space for a number of years. And yes, AI is becoming more prevalent and more of a focus nowadays, but machine learning's been around for decades and decades and decades. It was somewhat just called data science. And so high performance computing, quantum computing, which is a separate thing, has been around for decades, since the 80s. This isn't new to a lot of individuals who've been in this space. So they have gotten really comfortable with NVIDIA. And actually, for me, going back into school, using some of the TensorFlow models to build neural networks, and I'll actually show one, is that the people teaching me are comfortable with CUDA. So they are teaching CUDA. They're not teaching AMD's ROCm platform or Intel's new one that entered the foray of one API. So you're getting people buying NVIDIA GPUs. And yes, the NVIDIA GPUs do have that state-of-the-art architecture. There's companies, even for individuals that want to build upon things themselves, are going towards these H200s, these Blackwells, like Elon with X, formerly known as Twitter, and Tesla. And the reason I'm saying build upon themselves is because there's a big difference between the two. There's the ability to kind of like attack the market and kind of figure out a different way to overcome the Titan, the green boys, the NVIDIA, if you're AMD or Intel. They've both made their platforms open source. CUDA, closed source. The OEM, NVIDIA, original equipment manufacturer, gets to control the destiny of CUDA. And because they're doing that, people that leverage the platform can't really impute their own innovation and creativity. They can't fork it. They can't create anything else besides utilization of CUDA on top of NVIDIA GPUs. The pros of that, security for people that are also using it. The cons of it, again, can't really control your own destiny. Don't have the ability to impute your own creativity. And that's where AMD and Intel is kind of attacking it. These are both open source platforms, not really something you have to pay for. And you're able to kind of just optimize it in a way that makes sense for you. And I think that this is interesting. This is a cool way for AMD and Intel to pave their own fork in the road for developers. But there's a problem. Like you can see here, AI models and algorithms, PyTorch, TensorFlow, JAX. PyTorch and TensorFlow are very, very, if not the most popular neural network libraries that you need to create these models in Python. And I will actually show you one. When you're creating a model, you import libraries. And for me, TensorFlow, and there's kind of like a fork from my understanding. There's TensorFlow programmers and there's PyTorch programmers. I've been taught on TensorFlow. I'll learn PyTorch sooner rather than later, but TensorFlow requires GPU. And then when you're training your model, go through all the data science, all that stuff. This is kind of what it looks like. I've got a little baby 3090 Ti NVIDIA GPU behind me, but it's leveraging that to do all of the training, all the computations to come up with this bank churn model. That's what this was. It was a customer churn model for a bank theoretical problem statement for me to create for this project. But this is what it looks like. It needs the parallel processing power. And again, because my professors are familiar with the CUDA platform, that's what I'm learning. So there's an NVIDIA GPU in my at-home machine learning rig. But that doesn't mean that AMD and Intel won't overtake as 10 years catches up, and really there's going to be this exponential catch up. Like I think NVIDIA, because they led the way, had more of a linear kind of growth model because people were learning and developing. But we can see that people can take what they've learned from NVIDIA, if they like the open source of AMD and Intel, go over there, develop on it, and then they can kind of break out of an NVIDIA ecosystem. Because that's another thing that I'm seeing. NVIDIA is kind of becoming like this Apple, this closed ecosystem network. They're getting a lot of support from other hardware OEMs, software OEMs, because they are leading the pack. But if you want to opt for the more open source development, the more proprietary, innovative ecosystem, you don't want to be vendor locked in, then perhaps Intel and AMD is going to be something they're going to see from these more, I'll call, sophisticated environments within the enterprise. Someone that has like a lot of data scientists, machine learning engineers, theoretical physicists, computational neurosciences, whatever that they have on staff, and they just want to build upon themselves instead of developing on some sort of NVIDIA software stack. So the why right now is, again, CUDA. For me, this is my thesis on this, that yes, a lot of R&D has gone into the architecture, building upon NVIDIA, but I think on the back end, it's an effect because the cause is the fact that people like CUDA, they've built upon it. There's a lot of efficiency of running parallel computations. So they get the money, people pour money into it, they want that hardware, and then they take that money and they develop better and better hardware. So it's going to be a lot. It's going to be really difficult for AMD and Intel to catch up, but I think there is definitely a path forward there and something to keep an eye on. And really, that's the why. That's why I'm thinking 3.1 trillion. And a lot of GPUs are required to run these AI models, and people are onboarding onto them, wanting more of it, the generative AI. So the numbers just going to keep going up and up and up.